So, good morning to all. Today, let us discuss about the topic in satellite communication, that is satellite subsystems. Myself, Kasiviswanathan, Assistant Professor of Electronics and Communication Engineering, PSN College of Engineering and Technology, Tirunelveli. So, let us see about the introduction to satellite communication. In this, we are going to deal with today about satellite subsystem. So first of all, what is a satellite subsystem? So let us see one by one. This is the introduction part. In satellite communication, different types of operations normally takes place, as we all know. Out of this, the subsystem process and other things is very important for satellite communication systems. Among which of them are the main operations are the orbital controlling, altitude of satellite operations, monitoring and controlling of other subsystems such as telemetry, tracking and command systems. We will see it one by one. So in general, a satellite communication normally consists of the common two segments, that is space segment and earth segments. So what is a space segment and what is a earth segment? So there will be two types of subsystem. These are the space segment subsystem and earth segment subsystems, which are described here. And how these space segment subsystem and earth segment subsystems are communicated to one another through a means of communication link. So here is the communication link between space segment subsystems and earth segment subsystem. That is a two-way communication, so automatically duplex communication takes place here. So space segment subsystem for transmitting as well as receiving purposes. Earth segment subsystem, two-way communication is incorporated here. So what is a space segment subsystem? So in satellite, these space segment subsystems normally present in a space segment are segment subsystem. These are classified as AOC subsystem, telemetry, tracking and command monitoring subsystem, power and antenna subsystem and transponders. So these are all the different types of space segment subsystems. So earth segment subsystem is the meaning the subsystem present in the ground segment, usually our ground control stations such as GCS or ground monitoring station, GMS, etc. So the subsystem present in the ground segment have the ability to access the satellite repeater in order to provide the communication between the user. So this is the major objective of our earth segment subsystem. So in other words, earth segment subsystem is also called as ground segment system. Okay, well, here in this earth segment system performs mainly two function or operations. First one is the transmission as well as reception. Transmission of a signal to the satellite and at the same time the reception of a signal from the satellite. So two functions it mainly focuses. So earth stations are the major subsystem that are present in earth condition, that is ground control station level. So earth stations are usually located. We know that the satellite may deviate from its orbit due to the gravitational forces from sun, moon and other celestial bodies or planets. So these forces change cyclically over a 24-hour period, that is 1 day period, since the satellite moves around the earth. Now let us look into the AOC, that is altitude and orbit control. So the subsystem consists of rocket motors for launching purpose, which are capable of placing the satellite into the correct orbital orbit whenever it is deviated from that particular respective orbit. So here the AOC subsystem is helpful in order to make the antennas, which are of very narrow beam type, point towards the earth. So this is the attitude and orbit control system. So here we can make this AOC subsystem into two parts. First one is altitude control subsystem and this one orbit control subsystem. Let us see one by one. So what is your altitude control subsystem? The altitude control subsystem mostly takes care of the orientation of the satellite in its respective orbital path or orbit. So this is the main function of altitude control system. It takes care of the orientation, that is position and velocity and angular velocity and determination. All these things are taken into account to take care of the particular satellite in its respective orbit. So here we are incorporating two common methods to make the satellite that is present in an orbit as stable. So first one is spinning of satellite or spinning the satellite system. Then second one is 3-axis method. So these are the two common parameters for attitude control system, spinning of the satellite as well as 3-axis method. So what is a spin? Spin turnaround. So spinning of the satellite means the body of the satellite rotates around its spin axis. So this is the general definition for spinning. So it can be rotated at normally 30 to 100 revolution per minute in order to produce a force which is of gyroscopic type. So gyroscopic type of forces can act here. So based on this condition, the spin axis gets stabilized and satellite will point in the same direction. It does not deviate from its path. That type of satellites are called as spinning of the satellite system concept. Here the spinner component parameter normally contains a drum which is of the cylindrical shape. The drum is covered with the solar cells for power or charge as well and other providing for electricity. So power systems and rockets are present in this drum. Communication subsystem is placed on the top of the drum for transmission as well as reception purposes. An electric motor drives this communication system. In order to run the system, we need an electric motor for running purpose. The direction of this motor will be opposite to the rotation of a satellite body, so that the antennas exactly point towards the earth condition. The satellites which perform this kind of operation is called D-spin technique. Here during launching phases, the satellite spins when the small radial gas jets are operated. So this is quite naturally happens on each launching path. So after this D-spin system, the D-spin system operates in order to make the telemetry, tracking and command monitoring subsystem antennas point towards the earth station for achieving the results or outputs. So here you can see the spinning of the satellite around the earth. So normal spinning, the satellite exactly travels around the earth for transmission as well as receiving communication informations. So this is a satellite type of Galileo. Here the spinning concept is going on. So here you can see the body of the satellite with solar panels, different types of communication devices. Normally, orbit orbiting around the Earth. Solar cells for having electric power sources. Okay, hope you all understand. Now let us see about the 3-axis method. So 3-axis method, what is a 3-axis method? Here we can stabilize the satellite by using one or more momentum type of fields. In this manner, this method is called 3-axis method. As far as concerned, what are the advantages of this method is that the orientation of the satellite in the 3-axis, that is roll, pitch, yaw, will be controlled, and no need of rotating the satellite's main body. So here the main body of the satellite need not to be rotated. All these things are having by means of different axis system, that is roll, pitch and yaw. So what is roll axis? Roll axis is considered in the direction in which the satellite moves in an orbital plane. Yaw axis is considered in the direction pointing towards the Earth. Pitch axis normally flows which is perpendicular to the orbital plane. Here we can see through this schematic representation. So here you can see the roll axis, a rolling part, then pitch axis, pitch rotation. Similarly, yaw axis, that is yaw rotation to Earth center. Roll axis, direction in which the satellite moves in the orbital plane. Similarly, pitch axis is considered in the direction which is perpendicular to the orbital plane, that is roll. The next subsystem is telemetry tracking commanding, or simply called it as TTC command system. So telemetry tracking commanding monitoring subsystem is present in both satellite as well as the ground station, that is Earth station. Satellite gets data through different types of sensors and other instruments for information. The telemetry subsystem present in this satellite sends the data back to the Earth station or ground control station. This is very much necessary for any communication type of satellite in order to operate the satellite in a successful manner. TTC communication is a very essential and an important subsystem of satellite communication. Here you can see the TTC segment areas. Basically, this can be classified into 3 categories. First one, user segment, then command segment and space segment. User segment constitutes of transport vehicles commonly operated with transponders, that is transmitter as well as responder. Then command segment, monitoring ground control stations. We can transmit as well as receive the command based on the input as well as output which we receive from to the ground control station. Then space segment, quite oftenly it's a satellite. So satellite sends and receives the signal as well as communication information to the ground station. Here the uplink as well as downlink system plays a very important role. Here also the same concept is duplex type of communication is taking place. In this diagram we can see transmitting antenna, receiving antenna. that is two-way channel, two-way communication channel. Then telemetry receiver, then command transmitter, various commands and instructions to be transmitted to the satellite, and all these things are processed through data processor and different types of controllers, are structured in a single block. So here we are using some different components such as ranging tones for range measurements, monitoring system, especially for collecting data from sensors and other instruments, then telemetry monitor, digitalized data and encoded for transmission purposes, commands which are heavily encrypted, a part in many inbuilt checks are there. So these are the common structural parameters for satellite telemetry tracking and command. So through these transmitting and receiving antennas, the uplink as well as downlink frequency as uplink channel has been functioning throughout the period. So telemetry receiver collects the received information from the ground station as well as from the satellite. So based on the received instruction, if any command has to be transmitted, means it can be transmitted through command transmitter through the transmitter antenna. So now let us see the telemetry in a brief manner. In general, the word telemetry indicates measurement at a distance. So we have to calculate the long distance measurement. For that purpose, telemetry is quite being used for satellite communication. The following different operations takes place in telemetry. First one, generation of an electrical signal, which is proportional to the quantity to be measured. So, what are the measuring parameters to be needed? So, for that purpose, we have to generate some electrical signal. Then, similarly, encoding the electrical signals for a correct operation as well as process, and then transmitting that particular code to a far distance, that is long distance measurement. So long distance range. So for that purpose we are transmitting the same code. Here the telemetry subsystem present in the satellite, mainly in the satellite, perform two common functions, that are receiving data from sensors, transmitting the data to the earth station. Initially it collects the data, or it receives the data and transmit the same data to the ground control station or earth station. Similarly, satellites have quite a few sensors to monitor various parameters such as pressure, temperature and status of various subsystems. Here the telemetry data is transmitted as frequency shift keying or phase shift keying methodology. The telemetry subsystem is a RC system, that is remote controlled operation system. It sends monitoring data from satellite to the earth station, vice versa. The telemetry signals carry the information related altitude, environment and satellite system. So here we can see the telemetry tracking as well as command operations one by one. So waiting for contact. So establishing the communication and verifying the communication. Here pre-pass as well as post-pass operations are being carried out. verification of connection is going on, then critical health check monitoring condition, then execution of commands. All these parameters can be tracked by the TTC command system. So this is how the telemetry tracking and command operation process is going on through the ground control station. So next topic comes under tracking subsystem. So tracking is a very important one, because you have to know what the satellite is exactly doing at a present conditional level. So tracking subsystem is useful to know the position of satellite and its current orbit. By means of tracking, we can easily identify the satellite at which orbit is exactly located. SCC, that is Satellite Control Center, monitors the working and status of space segment subsystem with the help of telemetry downlink, because through the downlink information can be transferred. It controls those subsystems using command uplink. In general, whereas in the space, tracking subsystem is also present in an Earth station also. It mainly focuses on range and look angles of a satellite system. Here the number of techniques that are using in order to track the satellite, large number of techniques are there. For example, change in the orbital position of a satellite can be easily identified by using the data obtained from the velocity and acceleration sensors by means of some gyro systems that are present on the satellite path. Now, the tracking subsystem that is present in an Earth station keeps tracking of the satellite always and constantly when it is released from the last stage of launch vehicle. After releasing from the launch stage, that is stage is separation of a vehicle launch stage, what happens? The satellite and tracking command system has been activated. It performs the various functions like location of satellite in an initial orbit and transferring of orbit. So we discussed about telemetry first and tracking next, and last one, commanding subsystem. So what is a command? Command in general, which means gives instruction to the system. So commanding subsystem is necessary in order to launch the satellite in an orbit and it's working in that orbit. So how far the satellite is working properly in the orbital path. The systems adjust the altitude and orbiter of the satellite whenever there is a deviation in those fields or values. It also controls the communication subsystem, because communication subsystem needs very important part. So without communication, we cannot get any relevant information from the satellite as well as from the ground control station. So it also controls the communication subsystem. This commanding subsystem is responsible for turning on and off of other subsystems present in the satellite based on the data getting from TTC, telemetry and tracking. This is how the TTC operation is normally carried out in an area. So how these commands can be exchanged or transferred? It's a very important part. In general, here the control codes are converted into command words. So based on the command words, we are able to achieve the retrieved output. These command words are used to send in the form of TDM frame, time division multiplexing frames. The validity of command words is checked in the satellite. These command words can be sent back to the Earth station, and again these command words have to be checked and verified once again. If the Earth station also receives the same command word, then it sends an execute instruction to satellite. So suppose both signals are receiving the same command operational path, execution process or its instruction has to be informed to the satellite. So it executes that concerned particular command. Here, functionality wise, the telemetry subsystem and commanding subsystem are opposite to each other. The first one transmits the satellite information to the Earth station, and the second one receives command signals from the Earth station. So, two operational procedures are being carried out by the system. So, next satellite subsystem is transponder. So before going to the transponder, let us see this is how the transponder structure is functioning. So what is a transponder? Transponder in general term we classified as transmitter and responder. To transmit the information from one end to another end. Response in the sense after reaching the particular path or after reaching the area, we have to give a response command to the particular transmitted signal. Let us see about the transponders. Before that, I show you how transponder is functioning. The communication between the satellite as well as ground control station. So here the signals are transmitted to the ground control through the satellite. The transmitting antenna sends the signals. Similarly, in the ground control station, you can see a lot of receiving antennas are there. So the receiving antennas receives the signal based on the information prescribed. So here you can see other celestial bodies such as moon, stars, different celestial bodies, and different satellites are also may existence. So what is meant by a common transponder for satellite system? Transponder is a component of such system that receives the signal and shifts its frequency for transmission. This is the definition for transponders. This subsystem generally provides the connecting link between transmitting and receiving antennas of a satellite. So here there may be a connecting link, there will be a connecting link for transmitting as well as receiving areas of the satellite. Most important subsystem of space segment is a transponder. So in transponder, normally different blocks are there. Out of this, you can classify the major blocks here. You can show in block diagram of a transponder. So in the block diagram described here, illustrated here, duplexer, satellite antenna transmitting as well as receiving, then low noise amplifier, carrier processor, and power amplifier. So these blocks constitute and identified as the major blocks for the transponder system in satellite. So we all know duplexer. So duplexer functions is a two-way communication. It can transmit the signal and receives the same signal as and when required, receiving from the satellite. So low noise amplifier amplifies the signal. So here we have to reduce the noises. So for that, the signal strength has to be improved, and all those things are processed by a carrier processor for further proceedings. So these are the different blocks. Duplexer. Generally, duplexer is a two-way microwave gate which receives uplink signal from the satellite antenna and transmits downlink signal to the satellite antenna. This is a common differentiation between the two systems. Microwave gate signal which receives the uplink signal from the satellite antenna. Once it receives, it transmits the same downlink signal to the satellite antenna. So here also the uplink as well as downlink methodology is going on. The next one, LNA, that is low noise amplifier, it amplifies the weak received signal. Then carrier processor, it performs the frequency down conversion of the received signal, that is uplink signal in general. Power amplifier, it amplifies the power of a frequency down converted signal, that is downlink signal to the required level. So we have seen the block diagram, and then conversion technique. So after this, the conversion techniques has been carried out for converting the frequencies. Here, this illustration represents the block diagram of a transponder system for a 6x4 GHz band. You can see the block on receiving antenna with a frequency of 6 GHz, and then LNA, local oscillator circuit for conversion purpose. Similarly, IF, BPF, that is band pass filter, RF, radio frequency pre-amplifier, high pass amplifier, high power amplifier, and then transmitting antenna. Here the converted range of 4 GHz. So types, first one, single conversion transponder. It's one of the type of a transponder system commonly used for 6x4 GHz band or C band. Here the local oscillator, which is of 2225 MHz. These are the parameters required for a single conversion transponder. Also known as a bent pipe transponder, which receives microwave frequency signal. It converts the frequency of the input signal to the radio frequency, and then it amplifies the same. So here signal conversion process is being carried out for execution of output. In other words, this is also known as repeater and conventional transponder system. It is suitable for both analog as well as digital signals. So once again we will see the blocks. This is for a single transponder conversion. Here receiving antennas, low noise amplifier to provide a strengthened signal, then oscillator circuit, BPF, preamplifier, high power amplifier and transmitting antenna. So after full entire process is completed, the frequency range can be converted to the 6/4 GHz band. So next one is the regenerative transponder. The same process as of single conversion transponder. In addition, some demodulator circuits are there. Here also the same conversion process, that is uplink frequency, low noise amplifier, filters, oscillator for frequency conversion and demodulator for demodulation the signal, and then the data processing, and then after the processed data can be converted into the modulator, and then again it is amplified through a local oscillator circuit. And here we are using some filters in order to reduce the noise and sense the correct amount of signals. Then finally downlink frequency. It performs the function of bend pipe transponder along with the demodulation of RF carrier to baseband system. The regeneration of signals and modulation process has been carried out. This is also known as processing transponder. It's suitable only for digital signals. So the main advantages of this regenerating, it gives good signal to noise ratio and more flexibility in implementation part. So these are some of the different satellite systems, satellite subsystems such as TTC, telemetry tracking and command system, transponders, tracking and commanding, then AOC system. So these are all the different satellite subsystems so far we have seen. Once again we will see it in the next topic. Thank you.